Alright, continuing on with Chapter 12, Section 5, the volume of a pyramid and a cone. Before we get started, let's go back and review Chapter 12.4. We talked about volume of prisms and cylinders, and we know that those two have two bases. And yes, a prism is a polyhedron and a cylinder may not be, but their volume equations are still the same, talking about finding the area of the base times the height. So that equation will stay true to both of those. And now we're going to get into pyramids and cones. And those equations will also be true for both a pyramid and a cone. So looking at Theorem 12.9, the volume of a pyramid is going to be V equals 1/3 the base area times its height. And again, I know we've talked about the base, the big B being the base area, and of course the equation to find the base area will change depending on the base shape. So that is something we need to make sure we pay attention to. I have rewrote that equation, so volume equals 1/3 times our base area times our height of the solid. And notice that the height of the solid now is going to be the height from the center of our base to the common point on the top. Notice that the H, now that we're dealing with, is not the slant height. So let's make sure that we are identifying the specific things to put into our formula that are correct. We don't want to use that slant height. That slant height was used for surface area, so now we're just going to use the height of the solid, so from the point to the base. All right, so looking at example 1, finding the volume of our pyramid, and notice that it isn't necessarily a right pyramid, but using our Theorem 12.9, this formula will apply to both right and oblique pyramids. So first we need to find the area of the base using the formula that we used in the last chapter. Since it is a hexagon, we know it has 6 sides. So our area, or our big B, we're going to use the 1/2 the apothem times the perimeter. And just refreshing our memory on how we find that, our first step is to find our angle. So 360 divided by the number of sides 6 would give you 60, divided by 2 would give you 30-degree angle up top here. So if I know that one side is 2, using our special triangles, I know that our long side is 2 square root of 3, so that would be our apothem. So I checked that off. I also need to find our perimeter. So our perimeter is 6 sides times that 4, that length. So I would have a 24-inch perimeter. So now I'm just going to plug both of those numbers in to find our big B, our base area. So 2 square root of 3 times 24 would give me a big B of 24 square root of 3. So that's going to be our big B. Alright, and remembering our new formula, V equals 1/3 our base area times the height of our solid. We can just go ahead and plug those numbers in. 24 square root of 3 will be our big B, and our height, notice, from the point to the base, not on the face, but the height of it will be 10 inches. So if we simplify that, that will be 80 square root of 3, and that will be approximately 138.56. Cubic inches. Remember that since we're still in volume, we use the cubic units. So moving on, we just learned the pyramid equation. Now we can move on to the cone equation for volume. So same thing, 1/3 times the base area times our height. And remember that big B now, since we are dealing with the base as a circle, we can deal with the big B equation being pi r squared. Alright, and just a reminder, if you are putting that 1/3 in your calculator, remember you can put that parenthesis in there, and 1 divided by 3 can be one step in your calculator. So just a reminder with that. Alright, using that equation, V equals, our volume of a cone equals 1/3 pi r squared times the height. Not the slant height, but just the regular height of the cone. So, looking at A, our right cone, we know that this would be our height, and 9.5 would be our radius, so we are ready to solve our equation. So 1/3 times pi times r squared, which would be 9.5 squared, times our height, which would be 16.8. Simplifying that, we would get 505.4 pi, which would be approximately 1587.8 millimeters cubed, since we're in volume. Alright, let's label our oblique cone, and again, remember that 12.9 says we can still use that volume equation. 12 would be our height, and 4.5 would be our radius, so we are ready to start our equation. Again, 1/3 pi r squared times h. So we can say 1/3 times 4.5 was our radius, and 12 was our height. So simplifying that would be 81 pi, which is approximately 254.5 feet squared. So 254.5 feet squared. Remember, if I'm going too fast or you need to rewind to get some information, make sure you do so. Alrighty. So now we need to use possibly our trig functions maybe we need to find our height or our radius or something within that equation. We may have to use our trig functions. And just a little review, SOHCAHTOA, sine equals opposite over adjacent, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So they have kind of taken out that triangle that was created with the height, the radius, and the slant height. So we know that 12 is our regular height, which we do need for the equation. Do we need our slant height? Nah, we don't need that, but we do need our radius. So this would be, they have given us 62. So using that, this would be our adjacent side, and this would be our opposite side. So then we are going to use tangent. So we'll set it up, tangent of 62 equals opposite over adjacent, which we can fill in the blank. Opposite is 12 over adjacent, which is A, or our radius. Let's put radius there instead. So we would say 12 divided by the tangent of 62, which we would get approximately a radius of 6.38 meters. So now that we have our radius, we know we can solve for the volume of our cone, and we'll put pi r squared in there instead of our big B. Pi r squared times h. Alright, so we have our height, we have our r. So let's solve our equation. So 1/3 pi r, we got at 6.38 squared, times our height, which we look back up there, and that is 12. So our volume is approximately 511.5 meters cubed. Alright, and last, of course, our composite solid. So when we dealt with surface area and we had a composite solid, remember, we didn't want the two bases that were on the interior side, but now we do want that. We want to include that into our volume equation. So we are going to say the volume of this composite solid equals the volume of the cylinder plus the volume of our cone. So we're going to take the 12.4 equation plus the 12.5 equation to solve this. The volume of the cylinder plus the volume of the cone that we just learned. So let's look at the cylinder first. Remember, it's our base area times our height. So our big B is pi times our radius, which is 3 squared, times our height, which is 7. And that would give us 63 pi. And then for our cone, of course, remember now we need volume equals 1/3 pi r squared times h. So we know that our radius is also 3 centimeters. So 1/3 pi 3 squared times our height, which is 3. So simplifying that would give us 9 pi. And putting that all together would give us a combined volume of 226.19 cubic centimeters. So 226.19 cubic centimeters. After you get done there, write something that you're looking forward to class today, or freshmen, put something that you have heard that is fun doing on class day, because this will be your first adventure. Alright, after you get done doing that, why don't you stop this video and do your checkpoints on the next page, and I'll show those to you so you can check your answers, and then we will be ready to move on to 12.6. Here is checkpoint 1 and 2. And 3 and 4. Show all my work. Okay, so hope you enjoyed the video, and look forward to talking to you about it the next time. Bye.